Hello grade 12s and welcome to the second part of functions revision. So that's part 2. Please take it down. Okay, so number 1 states, given f of x is equal to negative 1 over 4x squared plus x plus 8. Calculate the x-intercept or x-intercepts of f of x. So as usual, x-intercept y is 0. So f of x is going to be 0. What is f of x? Negative 1 over 4 x squared plus x plus 8 is equal to 0. Divide everything by negative 1 over 4. Negative 1 over 4 x squared divided by negative 1 over 4 is just x squared, right? And then 1 divided by negative 1 over 4 is just negative 4x. And then 8 divided by negative 1 over 4 is negative 32. Then you just, so 32 is 32 times 1, 16 times 2, then it's 8 times 4. 8 minus 4 is 4. So put 8 here, we put 4 here. Give the bigger number the sign of the middle term. Right? So x plus 4 is equal to 0, or x minus 8 is equal to 0. So we have x is negative 4, or x is 8. So therefore the x-intercepts are negative 4, 0, and 8 and 0. 1.2 states, determine the y-intercept of f. Okay, this is fairly straightforward. Y-intercept, x is 0, right? So where does x we put 0? Which is just going to be 0 plus 0 plus 8, which is just 8. So therefore the y-intercept 0 and 8. 1.3 states, give the equation of the axis of symmetry of f of x. Remember, the equation of the axis of symmetry is x is equal to minus b over 2a, which is just, what is b? 1 over 2, that is a, negative 1 over 4. So x is 2. States, calculate the coordinates of the turning point of f. So we know that the turning point is at x is 2, right? So we need to calculate f of 2. Excuse me. So it's just negative 1 plus 2 plus 8. So f of 2 is 9. So the coordinates of the turning point are x is 2 and y is 9. Aha! Okay. 1.5 write down the domain of the. Now here we have to visualize. Okay, we don't have to visualize. The domain is just, because it's not restricted, it's x is an element of real numbers. Right? Then 1.6 states, write down the range of f. Range, you know, the set of y values, right? So this is where we have to visualize. Okay, please stay with me. Just use this. Your graph A is negative, so your graph will be a cap shaped or a frowning face, right? And then we know that at the turning point, we use the turning point to determine, we use the y value, y coordinate rather, of the turning point to determine, right? So 2 and 9. We know that the graph will start at negative infinity and end at 9. So the range is y is an element of, we don't know where negative infinity starts, so it's just negative infinity, and then it ends at 9. Corner bracket, don't forget, because it's an included value. 1.7 states, sketch the graph of f, clearly indicating the intercepts with the axis and turning point. Okay, just gonna, so negative 4 and 8, right? So here's negative 4, here's 8. And then y-intercept is at 8. Okay, let's put it at here. Then the turning point 2 and 9. So let's put it. Forgive me, I'm a sort of a perfectionist. So let's write our values. Then let's just join our points. So it's going to be, okay, just hope that's clear enough. Then this is the point, x is 2 and y is 9. This is the equation of the axis of symmetry. X is 2. Don't forget to label your graph. This is the graph of f of x is negative 1 over 4 x squared plus x plus 8. Okay, I hope that makes sense. Number 2 states, given g of x is equal to 12 over x plus 4 plus 6, determine the x-intercept of g. So you can see this is a hyperbola, right? So as usual, x-intercept y is 0. G of x is equal to 0. 12 over x plus 4 plus 6 is equal to 0. So we have 12 over x plus 4 is equal to, take this to the other side, it becomes negative 6 over 1. We cross multiply, right? Negative 6 times x plus 4 is equal to 12 times 1. Divide everything by negative 6. On the left we'll have x plus 4. 12 times 1 over negative 6 is negative 2. X is negative 2 minus 4. So x is negative 6. So what is the x-intercept? Negative 6 and 0. B. Calculate the y-intercept of G. So y-intercept x is 0. So we're calculating G of 0. So it's 12 over 0 plus 4 plus 6. 12 over 4 plus 6. 12 over 4 we get 3 plus 6. The plus 6 is 9. Y-intercept x is 0 and y is 9. Number C states, write down the equations of the asymptotes of g of x. Start with the horizontal asymptote. We know that y is q. And what is q? Q is 6, so therefore y is 6. Vertical asymptote, equate the denominator to 0. X plus 4 is equal to 0, so therefore x is equal to negative 4. I hope that makes sense. Number D states, write down the domain of G. So the domain is the set of x values, right? So it's going to be x. X is an element of real numbers. But what is the restriction? X is not equal to negative 4. because it never touches the asymptote. Right? What is the range of g of x? As usual, it's going to be y. Y is an element of real numbers, and then y is not equal to 6. Number F states, sketch the graph of G, clearly indicating the intercepts with the axes and asymptotes. This is going to be a bit of a difficult one, but let's see what we can do. So A is positive, right? A is 12. So we're expecting our graph to lie in quadrants 1 and 3. Start with the asymptotes. X is not equal to -4. Let's put it here. Y is not equal to 6. Let's put it here. And then we go to the intercepts. X at -6 and 0. So, somewhere here. Y at 9 and 0. So, somewhere here. So, -6. This is x. This is x is 4. X is -4 rather. This is 9. This is the line y is equal to 6. So, here and here, right? That's where we expect our function to be. Okay, I'm just gonna extend just so it's clear. So remember, it's a curve, right? It will, and then okay, then the other one is it will be like so. Remember, it doesn't touch the asymptote, but always approaches them. Okay, that is clear. Don't forget to label your graph. That this is the graph of, let's just write it here. G of x is equal to 12 over x plus 4 plus 6. Okay, I hope that was clear. Forgive me for the lack of space. But just make sure that these are curves, right? Okay, thank you very much and see you on the next part.